Going on from the preceding video, preceding clip, we have the question, okay, y prime of t plus p of t y prime equals 0. Can we talk about what the solution to this equation might be? As we saw before, if y of t equals e to the right thing, then y prime of t will equal negative p of t e to whatever that right thing is. Now, when we take the derivative of e to some expression, we're going to have to take the derivative of that expression, and that's what's going to come out in front here. Well, what do we put up here? Let y of t equal e to the negative p of t, and we find that y prime of t equals this is not what we do. We do this y equals e to the negative integral p of t, but to see why, we get y prime of t equals p prime of t e to the p of t, and that would be negative. And this isn't quite what we're looking for. Okay, if we let y equal e to the negative p of t, it doesn't quite work out. We get a p prime of t instead of a p of t. Our y prime of t would not contain the right coefficient function. So try this. Try y of t equals e to the negative integral p of t dt, where this integral could be any antiderivative. Then y prime of t is what? It's going to be the derivative of this integral. So it's going to be the derivative with respect to t of the integral of negative p of t dt, and that multiplied by e to the negative integral p of t dt. And that equals, well, the derivative with respect to t of an integral with respect to t is just the function that we're integrating. So that is going to give us negative p of t e to the negative integral p of t dt. So this is our solution. Now we're going to try to apply this technique to solve a couple of relatively simple equations.